Hey guys, I'm back online now. Sorry, I did charge my phone while I was doing online streaming, but I just realized that the other side of this cable isn't plugged in very firmly, so that my phone is not charged at all. So it's run out of battery very quickly. So we will continue working on this illustration on central limit theorem and law of large numbers. Okay, so for the probability of x bar less than 10, so if we do want to calculate that probability, we need we need to know the probability distribution, right? Oh, can you see me? Why it didn't show up? Why the video is not showing up? Let me have a check if it is working properly. Oh yeah, it's working. Wow, it's the problem on my side. Okay, well, forget it. So if we do want to calculate that probability, we need to know the distribution. So central limit theorem simply give us the sampling distribution of x bar. It tells us if for any distribution, any population, as long as the sample size is large, then x bar can be approximated by a normal distribution with the mean that exactly equal to the population mean, and the variance equals sigma squared divided by n. So it's going to be a normal distribution. So once we know the distribution of this random variable, we are able to calculate any probabilities corresponding to this random variable x bar. And this is going to be very helpful in our future applications on confidence intervals or hypothesis testings. Okay, so yeah, that's basically everything that you have learned in your first part of the semester or before the mid-semester exam. So now it's time for us to do the Q&A, and let's welcome Yvonne Song. Yeah. So Yvonne Song is asking if the covariance of efficient, so first of all, the name is not like that. So there are two things. One is called covariance, and the other is called coefficient of correlation. So I bet you want to ask those two things. So for covariance, both of them are measuring the association of two variables. But for covariance, the magnitude means how large or small the number, okay? The magnitude of the number doesn't make sense. So we can only know from the result, the covariance, whether there's a positive relationship or a negative relationship, but we can't say if it is strong or not strong, right? Because covariance has a unit in it. So for example, if you change your unit from dollars to Chinese yuan, right? Chinese yuan, then your covariance will change. So if you can recall the formula, it's probably for any distribution, it's x minus x bar, y minus y, no, not x bar, but ex, y minus ey, and then multiplied by its corresponding probability, right? Probability of observing x and y together. So in that sense, you can see x minus ex is $, y minus ey is $, so that the result of the covariance is $times $ is $2 squared. So that number doesn't really make sense. That's why the large or small of covariance cannot really say if the relationship is strong or not strong. We can only tell if the relationship is positive or negative. But the coefficient of correlation actually solve this issue by doing a standardization on the covariance. So the coefficient of correlation, usually denoted as rho. Sorry, let me have a cup of water. So this rho is defined as the covariance of x and y divided by the standard deviation of x times standard deviation of y. So that you can see by dividing standard deviation there, if we do have covariance, which is $2, standard deviation is $, standard deviation $, so it's basically cancelled out. So it cancelled out all the magnitude effect and the unit effect. Therefore, we have a rho from -1 to 1. So this is a perfect range. And for different values of rho, we can observe different combinations of y and x. So first of all, if rho equals 0, then we will observe x and y pretty much scattered randomly on this plane. And if we observe a rho that is equal to 1, which means y and x are perfectly linear correlated, therefore we're going to observe x and y's, all of them are on a straight line, okay? Strictly on a straight line. And what about in between 0 and 1? So if we have a rho, which is coefficient of correlation, which is from 0 to 1, then more likely we will observe a little bit of a positive relationship, but not as strict as rho equal to 1, okay? But still positive relationships. Similarly, if you observe negative ones, for example, if rho equal -1, then you're going to observe a straight line on this plane, y and x plane. And again, if it is in between -1 and 0, you will observe a negative relationship between y and x, but not a strong one, not as strict like this, but it's not like a scatter like that. So here are the 5 different scenarios that may happen on different rho coefficient of correlation values. So we can say the covariance only tells you the positive or negative stuff, but coefficient of correlation actually tells you not only positive or negative, but also how strong the correlation is between 2 random variables, okay? So this is basically all about the knowledge on covariance and coefficient of correlation, all right? Hopefully this answered your question, Yvonne Song, okay? All right, now, any other questions? Do you have any other questions? All right, so basically, I know you probably don't have any questions so far because most of you haven't started reviewing it yet. But again, in order for you to really achieve a good mark, I highly recommend you to watch the 3 videos, part 1, part 2, and part 3 on ED, okay? So on ED, I post 3 links, part 1, 2, 3 on ED, and they explain every single topic in a pretty much very detailed way, so that you may be able to see. So can we do some practical questions? So I don't have any resources on my hand, but for those 3 videos, you do have the practical questions of those 3 topics you covered in in 5002. So on that one, you may yeah, there are real examples in those 3 videos. So just follow the links on eDay, okay? The latest announcement on eDay, so that you will be able to get to know those questions, okay? They are very practical. All right. Any other questions? If you ask me in terms of any particular question here, I may be able to answer. But if you want me to provide any practical questions, I'm not part of this teaching team, and I do these things out of just voluntarily. I'm not even get paid by doing this, so I can only use whatever resource you have in hand. So you may ask questions, and I'm happy to answer. Okay. But if you didn't do any revision yet, I highly recommend you watch those 3 videos first. Okay. All right. So seemingly you don't have much questions to ask. And let's look at today's live streaming. I just give you a structure of what you've got or what you learn in before the mid-semester exam. And if you do want to know the detailed explanation, well, I'd first like all of you to follow the structure and do the revision on your own. And at the same time, if you do want me to explain anything in super details, you may go to the 3 videos I had for QBUS5001 students, because they had exams 1 week ahead. So they are basically the same thing, and you even get less topic than 5001. Like the portfolio diversification is not covered. Diversification is not covered in QBUS5002. Okay. So that is one thing that you need to pay attention while you are watching the 3 parts of videos. Okay, now so far that's basically all about today's live streaming. Again, there's no much time for me to explain everything in a very detailed way, so that times speed, you're gonna only spend 40 minutes to watch for each video, right? So yeah, it's gonna be very quick. All right, thanks for watching today, the 8 audiences. I know probably we didn't notify a lot of you regarding this consultation. So if for those of you who haven't checked their email regularly, he may not know this live streaming session, okay? But all right, that's all for today. Thank you very much for your watching, and I hope you enjoy your study, your revisions, and doing well in your exams. Thank you very much. I'll see you in PLGs. Great.